All right, guys, today was kind of rushed, so just a quick couple of notes about the lab. So you should have this already filled out, your color palette numbers, whole numbers, and your absorbance readings from the spectrophotometer. Okay, so I think most of you I looked at, so by the way, this is the relative rate, and this is the absolute rate. I think most of you, as long as this number looks like it's increasing, this is the one that I want you to graph down here, okay? So when you're graphing down here, it says graph either the relative rate or the absolute rate. Mrs. Flannery will tell you which one you're doing, the absolute rate. So you're graphing the absorbance, okay? So you're gonna have time, 0 through, so you can do a time at 0, which is 0 and 0. You're going to have time here, and then your absorbance here. Now, one thing about, don't forget, remember that, you know, all the elements of a graph, your title, and it has to have independent, dependent subject. But it's kind of tricky here because your independent variable, you know, what you're putting on the x-axis is time. What you're putting over here is the absorbance, which, by the way, does not have a unit. Just write absorbance and do your numbers. But you're not really, that's not what the lab about. The lab's not about measuring the absorbance over time. The absorbance, our actual dependent variable, is the rate of the reaction, okay? So, you know, you want it like in your title, like it kind of tells you somewhere, you know, that, you know, you're graphing the rate of the reaction and of the enzyme turnip peroxidase over time, right? Because you kind of, that's implied in the rate. But, you know, you might want to put like a little box or something that says this: higher absorbance indicates a faster reaction, right? Because a higher absorbance, just put like a little key here, or even put that in your title, like the rate of the reaction measured by absorbance, you know, over time. So you want to say something here like a higher absorbance indicates a faster rate of reaction. You know, maybe put a little addendum here. So just so we're clear what's in the graph, we're measuring the absorbance over time, but the absorbance is really telling us the rate of the reaction. Make a note there, or put it in your title so that that's clear. Again, don't forget all the things like units for time. There's no unit for absorbance. Scaling properly, and you should get a graph that goes that increases, right? Some of you it increased, and you might have gotten to the point where enzyme and substrate were used up and it leveled out. You might have got to the Vmax. Some of you it's just going up. So when you're calculating this, then it asks you to, like, so you're going to plot that. Then it says to calculate the baseline reaction, just like you're calculating the slope of the line, delta y over delta x. You can pick 2 points, you know, pick like the 0 and then like wherever it levels off, like when it's, you know, any 2 points on the line, and show me which points you used and calculate your baseline reaction rate, okay, calculated by absorbance over time. So everybody should be able to do that. I think everybody got part 1 done. Part 2, this part, let me switch over to, this was the group data. I think it's I don't think it's going to show perfectly. So for this page, as long as you have the 2 pHs or the one, for some of you that you just have your group data for whichever one you did, that's fine. You don't have to have this whole thing filled out. And I think I'm going to just scratch this. I hate to do it. I want you to use your own. But we only had like one person do pH of 5, and that number is a little higher than it should be. So I was intending to have 3 so we could average it, but it's not looking perfect. That's going to throw you off. Almost perfect. You're going to see, remember the pH graph, right? It looks like this. So when you plot it, it's going to look something like that. But I'm going to have you actually use that little piece of paper that I gave you in class, because this will give you this. If you don't have it, you can freeze this and write this down. This is what you're going to graph for part 2. So it gives you the pHs and then the average absorbance for the different pHs. All right, so again, for the second part, you're just going to do, don't forget all the same things about the graph. It tells you, let me go back to the lab. Okay, so you'll have just whatever ones you did filled out here, that's fine. Again, here, I'm telling you to do the absolute rate of reaction, graph the absorbance. It's going to be the same. Don't graph the color palette data. Again, title, don't forget, same kind of title. But this time you have pH down here, not time. Okay, and over here you still have absorbance, whatever. And it should look something, you know, like a curve when you plot it, all right? Also, let me remind you, so you can plot it, technically the type of graph you could do here. A lot of times you can plot it as a line graph because pH is continuous data, so you could plot the points and then draw the curve. Or it is appropriate to do kind of a bar graph that shows the curve. So either a bar graph or a line graph, which will be a curve, is fine. I do want to remind you though, especially if you do a line graph, remember the spacing has to be equal, whatever you decide. So we did, the pHs that we did a pH of 3, 5, 6, 7, 8, and 10, okay? Those are not equally spread out. That's 3 to 5 is a jump of 2, then a jump of 1, a jump of 1, a jump of 1, a jump of 2. So if you're gonna, you don't do this, 3, 5, 6, 7. That's incorrect because you're saying that that is the same as that, and it's not. So you need to do, you know, label the pH of all the pHs. You know, you could do like 1, you know, 2, whatever's going to fit, 3, I don't know if that'll fit, 4, 5, 6, 7, 8, 9, 10, whatever. You put all the pHs there, equal spacing and incrementing, but you will just have data points at a pH of 3 and a pH of 5, you know, whatever. Okay. Again, you don't label the x-axis with the pHs that we chose and make them equal spacing, and they're not equal. Again, if you have any questions, you can email me questions and I'll help you out. So that's it, and then the rest is just answering questions. All right, so that is the lab. Sorry we kind of ran short of time today. I'll see you Wednesday.